This is Unit 3, Moles and Stoichiometry. Lesson 2, Calculating Moles. How are moles determined? By the end of this video, you will be able to calculate the moles given the number of grams, and you'll be able to calculate the grams given the number of moles. So review due now. So converting grams to moles, we're going to use the mole formula from Table T. So it's called the mole calculation. So if you look on the back of your reference table, Table T has all of our formulas. The mole calculation is the number of moles is equal to our given mass divided by the gram formula mass. The given mass is the mass in grams of the sample. So how do we convert from grams to moles? You have to first calculate the GFM for the compound. You can round to the nearest tenth. 2, you're going to plug the given value and the GFM into the mole calculations formula and solve for the number of moles. So an example, how many moles are in 39 grams of lithium fluoride? So step number 1 is to calculate the gram formula mass. So we are first going to do our chart, is what I call it. So list each element, so lithium and fluorine. There is 1 lithium and 1 fluorine in this compound. We're going to multiply by their masses. So lithium, if you look on the reference table, is 6.941. So I'm going to round that to 7. And fluorine is 18.998403. So I'm just going to round that to 19. So then 1 times 7 is 7. 1 times 19 is 19. 7 plus 19 is going to equal to 26 grams per mole. And that is our GFM. Now to get the moles, I'm going to take the given mass. I'm looking for how many moles is what I'm looking for. And the given mass is the 39 grams of my compound. So I'm going to take the given mass divided by the gram formula mass, which I just calculated. So 39 grams divided by 26 grams per mole. If you look, our units will cancel out my grams, and that'll leave us with moles. So 39 divided by 26 is equal to 1.5 moles. 1.5 moles. So here that is listed out so that you can see clearly. Lithium is 6.9, fluorine is 19.0. If we round to our nearest tenth, we'll have 25.9 grams per mole. 39 divided by 25.9 is going to equal 1.51 moles. Example 2. What is the number of moles of potassium chloride present in 148 grams? So again, you're going to have to learn how to convert our words into formulas. The formula for potassium chloride is KCl. So we will first, 1, calculate our gram formula mass. So in KCl, I have 1 potassium and 1 chlorine multiplied by their masses. The mass of potassium is 39.083. So in this case, I'm going to round to 1 decimal place to show you that. Chlorine is 35.453. So I'm going to round to 35.5. So 39.1 plus 35.5 is going to equal our gram formula mass of potassium chloride. So that is equal to 74.6 grams per mole. Oops, I moved myself. Grams per mole. So here, using our mole calculation, the number of moles is equal to my given mass. Here's my given mass, 148 grams, divided by the gram formula mass, which is right here, which I just calculated. So 148 grams divided by 74.6 grams per mole is going to equal 1.98 moles. Or you can round that to 2. Okay, so here it is listed out so you can see it clearly. Determine the number of moles in 8 grams of boron. So now how are we going to convert from moles to grams? We're going to use the same mole formula, the mole calculation, and solve for gram by setting the mole over 1 and cross multiplying. So before we answer, we can check if I have more than 1 mole and the mass is great, then the mass will be greater than the GFM. If I have less than 1 mole, then the mass will be smaller than GFM. So that can allow us to check our work. So as an example, what is the mass of 4.5 moles of KOH? So first we must calculate the gram formula mass. So KOH, I have one of each, 1 times K is 39.1. I'm going to round to 1 decimal place, times H, 1.0, times 15.9. I'm just going to round that to 16. Oh, I did this. Excuse me. Look, I did O first, and I should have done, or I did H first, and I should have done O first. O is 16.0, and H is 1.0. So all of these times 1, so 39.1 plus 16.0 plus 1.0, that will get me, I messed that up, 39.1 plus 16 plus 1 is 56.1. That is the gram formula mass of KOH. So I want to know what the given mass is. So they gave me moles. So I have 4.5 moles. So then to solve for that, I'm going to say 4.5 moles over 1 is equal to my X mass over the GFM, 56.1 grams per mole. So 4.5 times 56.1 is going to get us 252.5 grams. So make sure your work is clear. I know I don't have a lot of space, but here it is clearly written out so that you can check your work. And if I round to my proper sig figs, I'll have 250 grams. So what is the mass of 0.5 moles of copper sulfate? So we'll do the same following steps. 1, calculate the gram formula mass. So I'm going to try and shrink my work a little so we have a little more space. There is 1 copper in copper sulfate. There's 1 sulfur in copper sulfate, and there are 4 oxygens. Times the mass of copper is 63.5. 63, I'll round to 63.6. Sulfur is 32.1. And oxygen is 16. So 1 times 63.6 is 63.6. 1 times 32.1 is 32.1. And then 4 times 16, we'll see is 64. So make sure you don't forget to do that. We're going to add all these together. So 64 plus 32.1 plus 63.6 is equal to 159.7 grams per mole. That is our gram formula mass, our GFM. I have 0.5 moles. So 0.5 moles over 1 is equal to my X mass over that number I just calculated, 159.7 grams per mole. So 159.7 times 0.5 is equal to 79.85 grams. And if I round to 2 significant figures, this will round to 80 grams. And that'll be our final answer. So here it is listed clearly so you can check your work and check your understanding. So you can now calculate the moles given the number of grams, and you can calculate the grams given the number of moles.